Welcome back. Today, we are building a data factory. We're going to look at the whole process of taking chaotic, unstructured, raw data and turning it into pure strategic gold using Microsoft Power BI. Let's get right to it. Be honest with me here. Are you running your business on guesswork or on evidence? It's kind of a painful question if you're currently dealing with mountains of unorganized data, right? But it immediately establishes the immense value of adopting a truly evidence-based strategy. I mean, you simply can't steer a ship effectively if you have absolutely no idea which way the current is flowing. So the real challenge is bridging that gap between the raw numbers and your actual strategy. And that is exactly what business intelligence, or BI, does. It's the technology-driven process of analyzing raw data and delivering actionable information. Think of it like this essential bridge between all that completely messy data on one side and the clear, strategic decisions your organization needs to make on the other. Here is the factory floor plan for today's explainer. 1. The power of business intelligence. 2. Connecting your raw data. 3. Transforming and cleaning data. 4. Calculations using DAX. And 5. Building the data model. Section 1, the power of business intelligence, from chaos to strategy. So why do we even care? Well, business intelligence literally eliminates guesswork by enabling data-driven decisions. It lets you predict outcomes through trend analysis, finding those historical patterns that tell you what's likely coming next, and it pinpoints bottlenecks so you can boost operational efficiency. It basically replaces I think with I know, which for sure is going to save you massive amounts of time and resources. And to actually pull this off, we use Microsoft Power BI. It's the ultimate cloud-based business analytics service. It's specifically designed to help absolutely anyone, not just hardcore computer scientists, visualize and analyze data with incredible speed, efficiency, and clarity. Okay, let's dive into this. Here are the 4 sequential steps our data is going to undergo on this assembly line. First, we intake the raw materials by connecting. Second, we refine them by transforming. Third, we add value by calculating. And fourth, we create the master blueprint by modeling. 4 clear, totally logical steps.
Section 2. Connecting your raw data, the intake process.
Right at the loading dock of our factory, what's genuinely amazing is the sheer variety of raw materials you can bring in using Power BI's Get Data feature. You aren't just stuck with one format. We're talking standard Excel workbooks, simple text or CSV files, massive enterprise SQL Server databases, scraping web HTML tables directly, or pulling from cloud services like Azure and Google BigQuery. Basically, whatever format your data is in, Power BI Desktop can probably grab it. Section 3, transforming and cleaning data, the refining process. Now, as anyone who has actually worked with raw data knows, it is notoriously messy. It's usually just a total disaster of typos, missing values, and absolutely bizarre formatting errors. To fix all that, we call in the cleanup crew, the Power Query Editor. This is the interface within Power BI where all of your data transformation, cleaning, and reshaping actually happens. And you access this powerful little tool simply by clicking the Transform Data button. Once you're inside the editor, you can run through a step-by-step cleaning process. You can filter rows, change data types so a date actually acts like a date, replace missing values, and remove duplicates. But look at that last point, because this is absolutely crucial: the Applied Steps tracker. It's this chronological list of every single transformation you perform. Make a mistake? You just delete the step in the tracker and boom, the data reverts back. Actually, scratch calling it a tracker. It's practically a time machine for your data cleaning. During this whole refinement process, you might find you need to create entirely new data out of the old stuff, and you have 2 main ways to add columns. You can go with a custom column, which you create manually by writing expressions using the M language, like, say, multiplying a price column by a tax rate, or you can use a conditional column. And this is brilliant because it uses a visual interface with simple if-then-else logic. So if the spend is over $1,000, label the row high. You literally don't need to write a single line of code for that. Section 4. Calculations using DAX, adding value. Okay, DAX. It stands for Data Analysis Expressions. It is the real math engine of our factory, where we add immense value. But you really need to know when to use the right tool. Calculated columns evaluate row-level logic. They're computed when you refresh the data, and they actually increase your file size. Measures, on the other hand, are computed on the fly as you interact with the report. They are highly efficient for aggregations and cause 0 file size increase. The golden rule? Use calculated columns for row-by-row categorization, and use measures for the heavy math and aggregations. Now, when you do decide to create a measure, you've got a choice: a new measure or a quick measure. A new measure means you're writing the DAX code manually from scratch. It's got a pretty steep learning curve, but it gives you unlimited complexity. On the flip side, a quick measure uses automatic templates. You just drag and drop fields, super low learning curve, though obviously limited to standard templates. Quick measures are perfect, beginner-friendly tools for tasks like, say, calculating a running total without having to write any code at all. Section 5. Building the data model, the final blueprint. Building a data model is really all about linking your tables together so they actually talk to each other. And they do this using keys. A primary key is a unique identifier in a table, like a specific product ID. A foreign key is the column in a related table that links back to that primary key. These keys are the essential connectors, the nuts and bolts that hold our master architectural blueprint together. And this brilliantly illustrates what those blueprints usually look like. On the left, we have the STAR schema. This is the standard performance-optimized model. You've got a central fact table containing your hard numbers, surrounded directly by dimension tables containing your descriptions. On the right is the snowflake schema. Notice how the dimension tables branch out even further into multiple, smaller, related tables, looking exactly like a snowflake. So why would you ever choose the snowflake over the star? Well, because the snowflake schema normalizes those dimension tables. It reduces data redundancy, which saves you storage space. But there's a trade-off, right? It increases the overall complexity of your model. And because the system has to jump through more hoops or multiple joins, it can actually slow down your query performance. You really have to weigh the space-saving benefits against the potential for a slower, laggy query. Which brings us to the very end of our assembly line today. Now that you have the blueprint, what will your data build? You understand the workflow to turn chaotic raw data into highly actionable strategic insights. The factory floor is officially yours. Thanks so much for joining me on this explainer, and honestly, I cannot wait to see what you build.